everyone, it's Justin again. I've recently been inspired by my friend Caroline's vegetable garden, so I want to start one too. Her garden is shaped like a square, and each side measures 5 feet. If each plant needs 1 square foot of space, I wonder how many plants she can grow. The area of a rectangle equals length times width, and since squares have the same length and width, we can also say the area equals a side length squared. So the area of Caroline's garden is 5 squared, or 25 square feet. This means her garden can fit 25 plants. That's a lot of plants to take care of. I want to start smaller. I wonder how long the sides of my garden need to be to fit 9 plants. For my new garden with 9 plants, I'll need an area of 9 square feet. I'd like a square-shaped garden too. How long do you think each side of my garden should be? Pause the video and write down your thoughts in the guided notes. Area equals side length squared, so what number squared, or multiplied by itself, equals 9? It's 3. The sides of my garden should be 3 feet long because 3 times 3, or 3 squared, equals 9 square feet. There's actually a math term for the process we just did. It's called taking the square root. Its symbol, which looks like this, is called a radical symbol. Let's try it with 9. We read this as the square root of 9. This tells us we need to think of a number that, when multiplied by itself, or squared, gives the original number under the symbol. Here, since 3 times 3, or 3 squared, equals 9, the square root of 9 equals 3. The square root is a mathematical operation, and like the other operations we've learned, it comes with an inverse. Addition and subtraction are inverse operations that undo each other, just like multiplication and division. Can you think of an operation that's the inverse of the square root? Let's think. If the square root of 9 equals 3, what operation undoes this, taking us from 3 back to 9? Pause the video and write your thoughts in your guided notes. To get from 3 to 9, we square 3, because 3 squared equals 9. So squaring and taking the square root undo each other. They're inverse operations. Now that we've learned what a square root is, how would you define it? Pause the video to read the definitions given by other students in your guided notes. Then write your own definition that'll help you remember what it means. I just remembered my friend Matthew has a garden too. He has 15 plants, so the area of his garden is 15 feet squared. So let's take the square root to find out how long the sides are. Remember that the side lengths must be whole feet, so each plant has 1 whole square foot to grow. What's the square root of 15? What number times itself, or squared, equals 15? 3 squared equals 9, that's too small, and 4 squared equals 16, that's too big. Maybe Matthew made a mistake. We can't find side lengths that make a square garden. Oh wait, Matthew didn't say his garden was square. His garden must be a rectangle with side lengths of 3 feet and 5 feet, because 3 times 5 equals 15. Well, that's very interesting, isn't it? Why can some numbers be the area of a square, but others don't seem to work? 9 works for my square garden, which has 3-foot sides, and 25 works for Caroline's square garden, which has 5-foot sides. Can you think of any other numbers that could work for a square garden? Pause the video to write down your thoughts in the guided notes. Nine worked because 3 squared equals 9. 25 worked because 5 squared equals 25. What about 1 squared? 2 squared? 4 squared? 1 squared equals 1, so the square root of 1 is 1. 2 squared equals 4, so the square root of 4 equals 2. And 4 squared equals 16, so the square root of 16 equals 4. That means 1, 4, and 16 could also be the area of a square. Let's keep this pattern going all the way to 15. Pause the video to fill in the chart in your guided notes. Here's what your chart should look like. Take a moment to make sure your numbers match mine. These numbers are called perfect squares. A perfect square is a number whose square root is an integer. Now that we know which numbers are perfect squares, let's try this. What's the square root of 16? Remember, we should think, what number times itself, or squared, equals 16? 4. 4 squared equals 16. Hang on. Is that the only number squared that equals 16? What if we try negative numbers? What's negative 4 squared, or negative 4 times negative 4? That's also 16, because a negative number times a negative number equals a positive number. This means there are two answers. There are a few ways to write our answer to include both the positive and negative roots. We could write negative 4 or 4, negative 4 comma 4, or plus or minus 4. So 16 has both a positive and negative square root. Do you think that's true for all of our square roots? It is. Pause the video to write the negative roots in your guided notes. It's common in math to work with only the positive square root. So when the radical symbol is given by itself, we only answer with the positive root. That's called the principal square root. If we want to indicate the negative root, we write this, the negative square root of 16. Here the answer is negative 4. To indicate both the positive and the negative root, we'll write this, which we read as plus or minus the square root of 16. This answer includes both positive and negative 4. Let's think about my garden again. If I was using the square root to determine how long each side should be, should I find the square root of 9, the negative square root of 9, or plus or minus the square root of 9? Have you ever measured something with a ruler or a tape measure and gotten a negative length? No. When we measure the length of a physical object, the measurement is positive. I need the square root of 9, which equals 3. While we're thinking about negative numbers, what if we try to take the square root of a negative number, like negative 4? The only way to multiply two numbers and get a negative number is with one positive and one negative. Positive 2 times negative 2 equals negative 4, but that's not squaring because we're multiplying two different numbers. Since we don't know any numbers that give a negative number when squared, we'll write no real numbers as our answer. Let's try evaluating a few more square roots. Pause the video here to try these out in your guided notes. Check your answers against mine. The square root of 49 is 7 because 7 squared equals 49. The radical symbol indicates that we're looking for the principal square root and should answer with only positive 7. Plus or minus the square root of 81 equals plus or minus 9. You could have written your answer in any of these three ways, but make sure you include both the positive and negative answers because of the plus or minus symbol in front of the radical. For the square root of negative 100, we should write no real numbers, because there is no real number that results in negative 100 when squared. Thanks so much for your help planning my garden. Today we figured out which numbers could be the area of a square garden, and we learned that those numbers are called perfect squares. To take the square root of a perfect square, we have to think of a number that, when squared, gives us the original number. All right, I'm gonna go decide what vegetables to grow in my garden. While I do that, finish up your guided notes and then complete levels 1 and 2 of the online practice. Until next time, keep questioning, keep calculating, and remember, when you see a radical symbol, you gotta get to the root of the problem. See you next time. Hey.